All right. Good morning or maybe afternoon. Um, Welcome to today. Today it's all about tree diagrams, getting some practice in and whatnot. So tree diagrams, that's your warm up. Try out the warm up and then you can continue this video or check in with the PowerPoint if you feel comfortable with just checking your work. If you want to hear a little bit more explanation about the warm up problems, then continue watching the video. Otherwise, you can use the PowerPoint that is on the Canvas page. Just a heads up, the 7.4 tree diagram quiz, that is going to be moved to Monday. A little bit more about that here in just a moment. So today's agenda, a warm-up, kind of split into three chunks: warm-up, group work, and homework work time. Depending on if we had a delay or not, some of this time might be restricted, so just go with the flow. Real quick about the quiz. So the 7.4 quiz coming up and the quiz that you've already taken. Those quizzes are in the gradebook, the 7.1 to 7.3. And then the 7.4 tree diagram quiz is going to be Monday. The plan is going to be to retake. It's going to be kind of an all-in-one. So after we take the tree diagram quiz on Monday, you will have the opportunity to see how you've done. And then the retake will be an opportunity to retake either or both of those quizzes at one time. So one side will be a retake for one of them, the other side will be the other. But if you're going to do both, then you need to do them all at one time. Okay, so look out for more information about that. But yes, there will be a retake option for both quizzes that we are taking or have taken. So the warm-up, pause the video if you haven't yet and try it out. Both sides, try them all, and then come back and watch the video or go to the PowerPoint and check your answers. Okay, so for the first warm-up, the musical instruments, tree diagram, there it is, given to you. Again, it never hurts to just go ahead and multiply the probabilities together for the combined events to get the combined probability of each event. So again, for example here, female violin, 0.12, and so on. So for part A, find the probability that a student is female, does not play the violin. So 0.48, you've already calculated that now, so that's just 0.48. Find the probability that a student does not play the violin. So any branch that represents not playing the violin needs to be added together. Remember, we got these probabilities. We got these by multiplying down the branch. And then part C, given the student does not play the violin, find the probability that the student is female. So remember, conditional probability, the given is your denominator. So given the student does not play violin, if you notice, we just calculated that probability in part B. So that should be your denominator, 0.76, and your numerator then is actually part A, 0.48. And that's the probability that the person is female and does not play violin. All right, so divide those two, and we get 0.632 to 3 sig figs. For the next one, the spinner. Again, the tree diagram, there's a lot of branches here, but if you were to go ahead and multiply through and just find those probabilities, especially when you have a lot of parts to answer, those can be handy just to have multiplied out straight away. You could use the fractions, that's fine too, but these decimals are also fine. Find the probability that black appears on both spins. So there's only one case where that happens, black, 0.25. Find the probability that the yellow appears on both spins. Yellow appears on both spins. Again, there's only one way that happens, yellow, right here. Different colors appear on two spins, right? So probability that it's different on both, you could take one minus the probability of the same color branches. So each of these three branches represents where you get the same color. So black, red, and yellow. So if you take away all of those from one, you are left with the probability that we get a different color. Part D, find the probability that the second spin was red, given the first spin was black. So again, there's the actual answer to that. There you go. So the probability that it was red, given the first one was black. Here's the formula, right? The probability that it's black, you need to, for your denominator, you need to add up these three probabilities for the denominator, and then you're going to put that under the probability that it was red and black. So red and black right here, 0.125. Okay, I guess I should have wrote that as black and red in that order. So divide those and you get 0.25, or 1/4 would be appropriate. Again, this situation is the one where we know that the probability, we know the given is that the first spin was black. So when you're given a piece of information about the first event or the first set of branches, you already know you're going down this branch, right? So we already know we are here. So that means then all we are really looking for is the probability that it's red, and that's the 1/4, or 0.25. But the formula always works. Okay. For part E, we have to use the formula. Find the probability that the first spin was black given the second spin was red. So we are given a piece of information about the second set of branches, and it's not as easy to figure out what the probability is without the formula. We have to use the formula. So the probability that given it was red, that means we are using the second one was red. These three probabilities, the ones in green, are the ones that are your denominator. And then the event that we're looking for is the probability that it was black given that it was red, which is this value right here. So that's why you have the 0.125 in the numerator. Divide those two things, you get 0.5 exact. All right, again, just to reiterate, when in doubt, use the formula for conditional probability, okay? If you're not sure when you can just kind of follow the branch and pull the probability straight from the tree diagram like we did in part B, or D rather, use the formula. Get comfortable with the formula. All right, for this one, if you didn't yet, try to draw a tree diagram to illustrate this situation, and then you can check it here. Here you can see a lot more notation, which is helpful to make sure you're understanding really what these branches represent. You can see the probability calculations of how you got each combined probability. So there's a tree diagram, and then we want to use that to find the probability that both will start. So both the car and the motorbike start is the top branch. So that's the 0.48. And then Carl can only use his car, which means if he can only use his car, that means only the car started. So the branch that would represent would be this kind of second branch here. So the car starts, the motorbike does not. So he can only use the car in this situation, so 0.32. Some extension questions here. Given the motorbike starts, what is the probability that the car also starts? Once again, using our notation, the probability that the car starts given the motorbike starts. So the motorbike is the given, so we want to add up the events where the motorbike starts. So that is the top branch and the third branch, and then put that over the situation or the event where the car and the motorbike start. So car, motorbike, 0.48. So simplify that, add the denominator, and then divide, and we get 0.8. That's exact. Probability that at least one vehicle starts. So we want to know at least one. A couple ways you can think about that. You either need to add up all three of these probabilities. So that means you can think of this as the first three branches, or you could take 1 minus the complement to the situation we're looking for. And the complement would be that neither starts. So 1 minus the probability that neither the car nor the motorbike start would get us the same result, 0.92. Okay. And then the probability that his motorbike starts given the car does not. So again, we're given a piece of information about the first set of branches. So this one, I should be able to just go, given that his car does not start. So I know I'm here. I know I'm right here. Probability that his motorbike does start is 0.6. So that should be my answer, 0.6. So I can use the formula to verify that, again, with my notation. So the probability that his car does not start, so that's these two branches. So these two probabilities added together is my denominator. And then this specific event right here, where the car does not start and the motorbike does, 0.12, that's my numerator. Simplify that, divide them, we get 0.6. Okay, so again, part E was a situation where I could use straight from the tree diagram, I could find that given or that conditional probability very simply. When in doubt, use the formula. All right, there was a video that I posted in the announcement from last Wednesday's e-learning that goes through some of the homework questions. Here's the key. It's also posted on Canvas. Couple things just to highlight here. Again, make sure you're recognizing that the branches, notice here the branches, these add up to 1. So when you're given spots to fill in, look at how many branches there are in all of the branches, right? And then, for example, if there were a third branch, well then all 3 of these branches would need to add up to 1. So you can use that to work backwards. Okay. So each set of branches, each pair, or each however many, add up to 1. All right. Again, tree diagram, useful in most of these problems. This one, kind of crazy tree diagram, but you can still use it to help you organize your work and figure out all the events that fit this criteria, and then your final answer, 0.663. This one was a little tricky for part D. Part D, you had to set up a little equation. And so in this case, if we want the quality control, the pass percent to be 93%, we need to write a little equation that takes, we know, so for D, right, supplied by D, we know 0.95 has a passing rate. So then whatever this percent that we take out of D is, we have to multiply that together for that combined probability. So that's where the 0.95 times, and we got to figure out what percent need to be taken or supplied by D in order to get that 0.93 probability. So this is the unknown right here. So this is what we're saying is X, right? So X times 0.95 plus, and then we don't want to use a different variable because that would make it impossible to solve the equation. So this probability then, right here, if this is X, then this probability is found by taking 1 minus X. And so that's where this comes from. So then the combined probability, 1 minus X times 0.9, we're using that to help us set up an equation, and then solve that equation, we get 0.6 or 60%. Okay. That was a pretty good extension question, good thinking question. This one, you could have used a tree diagram, but you could have also used the idea of a complement. If we want to know the probability of at least one boy is selected, then this is definitely a situation where the idea of a complement is a little bit easier. If we can figure out the probability that all girls were chosen, that is the complement to what we're really interested in. So taking 1 minus, and then if all girls are selected, right? Imagine traveling down the tree branch here of saying, okay, we got a girl, a girl, a girl, a girl. Each one of those is decreasing by 1 each time. And so we multiply all that together and subtract from 1, and we get the probability that we actually want, which is that we get at least one boy. All right, so at this time, if you haven't been moved on yet, when you are moved on, you need to go and work on the group work questions. At this point, with me not being there in terms of group work, you're just working in your small groups at your table. So it's either partner or a group of 3. So you just need to make sure you're helping each other, ask each other questions, but you're just working on, these are in the packets, the 7.4 packet from last class period. So you should have a copy of these already. They're in the PowerPoint as well. So you can pull up the PowerPoint and check your answers as you go. I would definitely make sure to do the tree diagram ones. There are some other probability questions mixed in there. So if you want to jump to doing the tree diagram questions first to make sure you've got those down for Monday, do that. Otherwise, if you have time, go ahead and get all 7 of them done. Like I said, I don't know if you had a 2-hour delay today, then you will be a little more crunched for time. Okay. Once you're done with these, then as a group, if you're done, then you move on to the 7.5 video notes.